Okay, we are given point -9, -7, and we are given the equation of the line y is equal -3x plus 5. So our task is write an equation for the line in point slope form and in slope intercept form, so that line is going to be parallel to this line and passing through this point. So one more time, our task is write down the equation of the line in these two forms, slope intercept and slope point slope, that is gonna be express the graph that is running parallel to this -3x plus 5 graph and passing from point -9, -7. Okay, so how are we gonna start? First of all, let's remember the point slope equation. Y minus y1, remember? Y minus y1 is equal m times x minus x1. So this is my x1, this is my y1, okay? And where is my slope? This is my slope, -3. So let's plug. M is equal -3. So at this point I can plug y minus my y1 is -7, okay, equal m is -3, and then x minus x1, which is -9. All right, so we are going to get y plus 7 is equal -3 x plus 9. Now this is our point slope form. Okay, now to write this equation in the form of slope intercept, I have to find y from here. Y is equal -3x plus 9, and moving this 7 on this side, which be -7, and from here y is equal -3x, oops, I messed up here, looks like. Hold on, let me fix it. So it's going to be -3x, I'm distributing, minus 27 minus 7. Okay, which means y is equal -3x minus 34. So what do we, conclusion we can draw? That this graph of the equation y is equal -3x minus 34 is parallel to y is equal -3x plus 5. Why is that? Because they have the same slope. When for two graphs, when slope is the same, and I don't mean to find the slope for this format. No, it has to be format of y is equal mx plus b, which is this one and this one. You have to bring to ms plus b before you consider the slope. Okay, so -3, -3, in both equations the slope is the same. That's why these graphs are running parallel. And the graph of equation negative 3x minus 34 running through the point negative 9, negative 7. Okay? Question number 2. Now we're going to do next question, similar. Oh, this time we're going to do the perpendicular. So again, we have to write down equation, the line of which will go through positive 9, negative 4, and is going to be perpendicular to y is equal 1/2 of x plus 3. Perpendicular. Okay, how much is m here? M is equal 1/2, right? Okay. When we have perpendicular, then for lines to graphs to be perpendicular to each other, their slope has to be negative reciprocal, which means if the m for this equation is 1/2, then the slope for the perpendicular line is going to be reciprocal, which is 2/1 and negative. Okay, so from here, using y minus y1 equal m times x minus x1, I'm going to plug values. So y minus y1 is negative 4. Here it is, y1, x1. Y minus y1 is negative 4 equal m is negative 2. X minus x1 is 9. So from here, y plus 4 is equal negative 2 times x minus 9, which is point slope format. To get slope intercept format, we need to find y, which is going to be y is equal negative 2 x minus 9 and minus 4, because I move 4 on this side, which will going to be negative. So from here, y is equal negative 2 x minus, let's open it actually. Nothing hold back from opening. So negative 2x and plus 18. Negative 2x plus 18 minus 4. We get y is equal negative 2x plus 14, right? Like terms. And this, the graph of this equation is perpendicular to y is equal 1/2 x plus 3. Why is it perpendicular? Because we have slope as a negative reciprocal. 1/2, you flip 1/2, it's going to be 2, and with negative sign, going to be negative 2. Okay, that's all. Next one, question number 3. Again, we need to do parallel, but the equation given in general form. So we have point negative 8 and 2, and our equation 5x minus 9y minus 7 is equal 0. Now, to insist here that 5 is a slope is absolutely wrong. Remember in the previous example I told you we have to bring to the slope intercept format, which means need to find y. Negative 9y is equal 5x moving here and negative 7 moving here, so 5x is positive. Now becomes negative. Negative 7 is negative, and then plus 7 is positive. dividing by negative 9, right? This is gone, and we are getting y is equal positive 5 over 9x and minus 7 over 9. Now from here we can insist that 5 over 9 is our slope. Okay? So m is equal 5 over 9. So we need to write down equation, the graph of which is parallel. So to have parallel, I'm going to use the same slope, right? And then y minus y1 equal m times x minus x1. All right. So y minus my y1 is here. This is x1. So y1 is 2 equal m is 5 over 9 x minus x1. x1 is how much? Negative 8. Okay. Y is equal 5 over 9 x plus 8 and plus 2. So these two I moved over here. And I'm getting y is equal 5 over 9 x plus 5 over 9 times 8 and plus 2. So let me see. Y is equal 5 over 9x plus 5 times 8, 40 over 9 and plus 2. Okay, so this form, this is our point slope form. Yes, and here it doesn't ask us to put in the slope intercept format. It's asking for general form. General form is just like this one is given. 5x minus 9y minus 7 equals 0. General form. Okay, for general form we need to bring two common denominators. Look at that. Common denominator is 9. So to bring 9 as a common denominator across the board, here divide by 9, multiply by 9, because whatever change we do to numerator, we have to do to in denominator, we have to do to numerator also. 2 also has denominator 1, therefore also here is 9, here is 9. Do I have here 9, 9, 9, 9, or every single term? Yes, that means I can drop this denominator and I will get 9y is equal 5x plus 40 and then plus 18, which means 9y equal 5x plus 58. And in the general format, like the original one is given, it's going to be 5x. I'm moving 9y on this side, minus 9y plus 58, and it's equals 0. So I moved everything on one side and left 0. So this is equation of the line in the general form. And this equation is running parallel to, where was that? 5x minus 9y parallel to 5x minus 9y and minus 7 equals 0. Now, if we wouldn't know that we did all these operations, if somebody would give it to me, I could only guess that they are parallel, because then y is 9, negative 9 has coefficient, and x has coefficient 5, but I had to go through all these operations I did to assure that they are parallel. Okay? Next question, the same thing we are going to do towards a perpendicular line, and it's given in general form. So we have points 8, negative 5, and we have the equation of the graph x minus 2y minus 5 is equal 0. Okay, so first of all, we need to write down in the format of slope-intercept. Let me see. Since my y is, I get negative 2y, so I'm going to move negative 2y on here to get positive. So which will be x minus 5 is equal positive 2y. Okay, and dividing by 2, I will get, this is gone. So y is equal x over 2 minus 5 over 2, right? I can separate this division by 2, so if it's confusing for you, there we go, x over 2, 5 over 2. There we go. So this is slope-intercept. My slope is how much? My slope is 1/2, right? X over 2 is 1/2 of x. Since we need to write down the equation of the line that is running perpendicular, then my new slope is going to be, slope of perpendicular line, it's going to be m is equal negative 2 over 1, which is negative 2. Negative reciprocal. So we flip it and take opposite sign. So from here, we get y minus y1 is negative 5 equal m is negative 2 and x minus 8. So I use these points. It's x1 and y1. So from here, y plus 5 equal, let's distribute negative 2x plus 16, right? Okay, we move everything on one side. Negative 2x. Let's move on this side. Y plus 5 plus 2x minus 16 equals 0. I moved everything on this side, and this on this side, and this on this side. And that's why negative 2x, I got positive 2x, positive 16, I got negative 16. And we are getting y, like terms, it's going to be negative 11, right? Y plus 2x minus 11 equal 0. So which means y plus 2x minus 11 equals 0 is perpendicular to the equation. Here it is, 5x minus, no, not this one, I'm sorry. Is perpendicular to, let me clean this, perpendicular to x minus 2y minus 5. Let me write down. X minus 2y minus 5 equals 0. Okay? Okie dokie. Question number 5. All right, we are going to transfer of functions. So, we are given function this one, this one, okay. Let me see, one coordinate is 1, 2, 3, 4, -4, 1 point. Let me see, 1, 2, 3, 4. The other one is going to a -2 and 3. This is 3 and this is -2. Coming here, and then it goes to 2 and -3. 1, 2, 1, 2, 3. Okay, third point, and last one is 4. So the graph goes like this. From here comes here. Okay, then from here coming here, my graph, and then from here coming here. This is the graph f of x. Using this graph, we are going to build g of x that is equal f of x minus 2. Okay, when we have minus 2, is this a change of x or y? This is a change of y. This minus 2 is a change of y. When would be change of x? If I would have f of x minus 2, that would be change of x. So what does that mean? And minus 2 is change of y, which means I'm going to fix every single coordinate here on this graph, and from the coordinate of y, do minus 2. For example, here for this point, coordinate is -4 and 0, yes? For this one, coordinate is -2 and 3. For this one, coordinate is 2 and -3. And for this one, coordinate is 4 and 0. Okay? So the coordinate, okay, let me build and I will go over. So this one, all right, so it's gonna be 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. Okay, we need it. Okay, the point, let's see. Let me take this one. We have, let me write out all these my coordinates. We have -4 and 0. We have -2 and 3. We have 2 and -3. And we have 4 and 0. All right, let's see what we're gonna get. -4 and 0. My y here is 0, right? So my y is gonna go, I'm going to do -2. So which means my new coordinate is gonna be -4. 0 minus 2, it's gonna be -2. Now, my second one, -2 and 3, my y is 3. So 3 minus 2, it's gonna be 1. and then 2 and negative 3, new coordinate, it's going to be 2, and negative 3, negative 2, it's going to be negative 5, yes, and 4, 0 minus 2, it's going to be negative 2. We understand? Because our change of y, negative 2, from every single value of y, I did minus 2. And this is the result of new function and transferring by negative 2. So let's go. Negative 4, negative 2. This is, let me see, x is negative 4, 1, 2, 3, 4, negative 4, and negative 2. This is my new point. Next, negative 2 and 1, negative 2 and 1. This is my second point. Third, 2 and negative 5. This is 2, 2, 3, 4, 5. Here we come. Let me zoom it so you can see. 2 and negative 5. And 4 and negative 2. Where is it? 1, 2, 3, 4. And negative 2. It's coming right here. So, what we get here? This comes to here. This comes to here. And this comes to here. So look here. This here we have f of x, and this graph we took and transferred, moved down by negative 2. And what is interesting, pay attention, this point, see, it was going through 0, right? Where is this point now? Right where negative 2 is. So we moved the graph by negative 2. And not to mess up the coordinate, we just subtract from every single coordinate negative 2. Okay? Next. Question number 6. Question number 6. So we are going to have use the same graph. Let me see if I can copy and paste, not to build the whole thing again. Okay. Oh. There we go. We made it. Okay. This graph, using this graph, now we are going to build change of x. Okay, which is going to be g of x is equal f of x plus 1. Okay, so when we have x plus 1, that means we are fixing here change of x, right? Not y. From my previous videos, I explained that the x is changing to opposite of the direction is given. Let's say if I have x plus 1, then it's going to move towards negative 1. If I have x minus 3, it's going to go towards positive 3. Where from it's coming? Because if I put x plus 1 is equal 0, I'll get x is equal negative 1. So it's shifting by negative 1. Why it's not happening in a case of change of y? Because let's say here, see, I took y is equal 0. But here if I take x is 0, so this would be 0. If I take x 0, this would be 0. And my y will be equal clearly negative 2. Okay, in the case of x, it's completely different. It goes opposite direction. Therefore, since we have x plus 1, every single the x coordinate is going to change by negative 1. So let's write down now. We have negative 4 and 0. We have negative 2 and 3. We have 2 and negative 3. And we have 4 and 0. So let's now transfer to x plus 1, which is I'm going to do minus 1 from every single x. So negative 4 minus 1, it's going to be negative 5 and 0. Negative 2 minus 1, it's going to be negative 3 and 3. 2 minus 1, it's going to be 1 and negative 3. And lastly, 4 minus 1, it's going to be 3 and 0. Okay, let's build this graph now, meaning transferring. How are we going to transfer through these points again? So, let's see. Okay. And the other one. So let's go. I'm going to go here 1, 2, 3, 4, 5. Okay, here I'm going to go 1, 2, 3. That's all I need. Up I'm going by 3. Down I'm going by 3. 1, 2, 3. 1, 2, 3. Well, let's start building point. First one, negative 5 and 0. There we go, negative 5 and 0. Next, negative 3 and 3, negative 3 and 3. Next is 1 and negative 3, positive 1 and negative 3. And lastly, 3 and 0. There we go. So now, let me connect it. Okay. And the last connection. Here we go. Now, if you compare these two graphs, don't you see the entire graph has shifted by negative 1? Let me write down negative 5 and 0, negative 3, positive 3, 1, negative 3, and 3 and 0. See? Every graph. And the point here that was 0, going through 0, now it's going through negative 1. See? There we go. We understand? Question number 7. All right, now here we are going to have both shifting by x and y. This is going to getting more fun. So, okay, again, copy paste. We have it. Okay, so we need to write down, so using this graph, we need to graph the function g of x is equal f of x minus 4 and minus 2. So in this case, we are going to change nx and y. All right, let's write down. So we have negative 4 and 0. We have negative 2 and 3. We have 2 and negative 3. we have 4 and 0. Let's go. First I'm going to change x's, and then I will change y. Okay, x. So I have x minus 4. Therefore, my x is going to change by plus 4, right? So negative 4 plus 4, it's going to come 0. Negative 2 plus 4, it's going to come 2. 2 plus 4, it's going to come 6. And 4 plus 4, it's going to come 8. Okay, now y is going to change by negative 2. So what we see, what we get. So if it's negative 2, every single y is going to go by negative 2. So 0 minus 2, it's going to be negative 2. 3 minus 2, it's going to be 1. Negative 3 minus 2, it's going to be negative 5. And 0 minus 2, it's going to be negative 2. So we practically changed an x and y. Yes? Okay. Now let's move this point on the new graph. And we will need big numbers 6 and 8. Okay, that's going towards, okay, we'll make it. And the other one, all right. So positive 1, we need all the way 6, 8, 1, 1, 2, 3, 4, 5, 6, 7, 8. Yes. Next, on this side, I don't have negative. Okay, it's completely gonna move to positive 1. All right, so y is going to be till negative 5 maximum. 1, 2, 3, 4, 5. And positive is going to be 1, 2 maximum. So we are good. So let's start. 0, negative 2. Here it is, 0, negative 2. 2 and 1. This is 2 and 1. Next, 6, 1, 2, 3, 4, 5, 6, and negative 5. And lastly, 8 and negative 2. Let's see what we got. This is first piece. Then we have second piece. Then we have last piece. Now compare, see what we got here. This is our graph. Let me see, I can zoom it. Like that, so you will see. So this coordinate is 0, negative 2. Here, this coordinate is 2 and 1. This coordinate, 6 and negative 5. And this one is 8 and negative 2. And this is how it moved the graph. Did I do something wrong? Let me see. No. Okay. Everything is all right. All right? Next. Question number 8. Okay, for question number 8, we have different graph. Well, it's similar, it just coordinates are different. Okay, we can use it. Number 8. So let me see what we have. One, and then another one. So 1 point is we have -4. One, two, three, 4. The other one is 2 and 6. 1, 2, 3, 4, 5, 6, and this is 2. 6, and this is -2. Okay, then next one, 2 and -6. 1, 2, 3, 4, 5, 6, and here is 1 and 2. And lastly, 4 and 0. 2, 3, 4, and 0. Okay, let's connect. This comes here. This comes here. And this comes here. So what are our coordinates? Let's write down. -4 and 0. Here we have -2 and 6. Here we have 2 and -6. And here we have 4 and 0. Okay. Now we're gonna build, let me see, g of x is equal -f of x. Negative f of x. Which means -f of x, since f of x is, my f of x is y, which means I am going to build -y, which means every single y, I'm just going to flip the sign. Okay? Let's see. So I have -4 and 0. I have -2 and 6. I have 2 and -6. Let me fix this. And I have 4 and 0. So every single y is gonna flip the sign. Since in this case I have 0, then I don't have what to flip. It's gonna stay the same. So I have -2, 6 become -6. I have 2, +2, -6 become +6, and 4 and 0 stays the same. Let's build it. So, oh, I will need to use -6, so there we go. Let's see here. Oh, no, this -6 is for y, the opposite. I need this one longer. Okay, so I need here 1, 2, 3, 4, 5, 6. Okay, I have 1, 2, 3, 4, 5, 6. I need here -4. 1, 2, 3, 4, 5, 6. this is 6, negative 6, and here positive 4 is enough. 1, 2, 3, 4. Let's start. Negative 4 and 0, and then negative 2 and negative 6, positive 2 and positive 6, and I have 4 and 0. So the graph is coming like this. Here. The graph is coming like this. And like this. Okay. See, it's the graph has flipped. Here it's coming first going up and then down. Here is going down and then up. And here is going up, here is going down. Yes? So the graph flipped because we have a negative f of x, which is your y is gonna change on negative. Okay? All right. So let me write down coordinates, negative 4 and 0. Here we have negative 2, negative 6. Here we have 2 and 6. Here we have 4 and 0. Question number 9. All right. In this example, it's going to be difficult for me to graph precisely because it's going to be parabola. There is no template for parabola, so I'm going to draw by hand. So forgive me if it won't be precisely the way it's supposed to be. So let me check if we have here something. No. Well, at least I can try this. So we have x squared. We have our f. We need to graph. Okay, we have f of x is equal x squared. So x squared is going to be something like this. And now and these sides have to be symmetrical. Okay, this is our f of x. Now we need to build the graph f of x squared actually I don't even need that. We need to build the graph g of x is equal x squared minus 4. So in this case, you can take any 2 points, again go by point. or since we have parabola, it's easy to take this minus 4 is a change of y, right? So 1, 2, 3, 4, and move it parallel down by 4. So this will be x squared minus 4. Okay? That's exactly how we are going to build. It's very easy. Next one. Question number 10. So for question number 10, we are going to build based on f of x is equal x squared Let me move on this side. Okay, so you know how I could build, make sure I'm building precisely. So if x is plus, if x is equal plus or negative 1, then x squared still gonna be 1, right? So, which means I can take here negative 1. So this is y, it's gonna be 1 still, and here is also positive 1. So by these 2 points I can connect and draw it. Okay, so this is x squared. Now our goal is to build g of x that is equal x plus 4 squared. So look the difference. This is change of x, change of y, I'm sorry. Here we have change of x. Okay? Since we have plus 4, which means we have to take the graph and move to negative 4. So where is my negative 4? 1, 2, 3, 4. So I'm taking the graph and moving parallel to negative 4. So I can move this y-axis like that. So it will go through this negative 4, right? And build the graph based on that. This is negative 1. Okay, meaning negative 1. It's not negative 1. This is negative 4. This will be negative 5. This will be negative 3, right? Plus minus 1. And this is 1 also. Negative 4. This is 1. So these 2 points. Okay. Let me build. Wish me good luck. Not bad. Not bad at all. And so this is x plus 4 squared. Okay? Moving to next question. This is question 10. Moving to next question. So we're going to build the same graph, but negative 1. So question number 11. We need to build, let me take different color. So we need to build f of x is equal negative x plus free squared. All right. So let's build first the x squared. Okay. So this is -1, this is +1, here is also 1. So those are my point, it's gonna go through. So my graph, it's gonna go, no. Okay, use your imagination, it's supposed to be parallel, and I mean not parallel, symmetric. And it's not symmetric at all, far from symmetric. Okay, this way. Well, better. So x squared, this is f of x is equal x squared. Now we're gonna build negative x plus 3 squared. So first we are going to do, because it's negative, that means my y is gonna be negative, which means this graph is gonna flip down, because right now its graph is completely on the positive y area. So since in front of my equation I have negative, so I'm going to build x plus 3 squared and then flip down to get y negative. All right, x plus 3, which means graph I'm moving towards -3, right? This is 1, it's gonna be 2, and this is 3. Okay, so this y-axis moving here. So -1, +1, and the same this point, this point. Okay? How so? This way and with this way. Okay, not bad. So this is our x plus 3 squared, yes? Because this is -3. Now we need to flip it down. So if I flip it down, my graph is going to look like, so this is -1, move down, -1, these 2 points. So it's gonna come this way and gonna come this way. So we flip down, and this is our negative x plus 3 squared. Okay? I hope I make it clear, understandable. So x minus 3, x plus 3 squared with negative sign. All right. Question number 12. So using transformation of x squared, now we're gonna build, what we're gonna build? So using transformation of f of x squared, we're gonna build the graph x minus 3 squared plus 4. Okay, we are going to get both changes, an x and y. All right. At this point, it doesn't matter if I first change x or change y. Let's start. This one. Actually, no, we're good. So this is one. This is one. This is one. These 2 points. Graph is gonna go this is my x squared. We always start from original one, x squared. Now, okay, let's move first, do x minus 3 squared. So I have to move to positive 3, right? Since I have x minus 3, this is 1, this is 2, this is 3. Okay, my y-axis. My y-axis moving here. So negative 1, negative 1, positive 1. So the graph is going to go that way. Yeah, okay, I can use this. So it's going to go this way and this way. This is going to be x minus 3 squared. And now I need to move, since y is plus 4, I need to take the graph and move by 4. So this is 0, so 1, 2, 3, 0, 4, right here. So let me see, the x-axis gonna move to here. Yes, this is my x moving here. Okay, so what's gonna happen here? This is plus 1, minus 1, minus 1. So it's gonna go through these points, and my graph is gonna look like use your imagination. Okay, and we are getting, this is going to be x minus 3 squared plus 4. This point here is called vertex. What is going to be the coordinate of this point? So x is what? 4? I mean, x is what? 3? And y is how much? 4. So vertex is going to be opposite sign of x and direct sign of y. So 3 and 4. Okay? Question number 13. This is getting more interesting. We need to, based on transformation, we need to build a graph g of x is equal 3 times x minus 6 squared minus 5. So instead of x squared, see, I have here 3. So I have to build 3x squared first. Okay. Let's do that. Did it go wrong? Yeah, of course. It's not straight. All right. let's start. So we need to build x squared first, and then 3x squared. So my x squared is going to be, this is my 1, here is 1, here is also 1. So it's going to be this point, this point. So I'm going to go by dashes because this is not going to be my main. It's much easier by dashes. Okay, so this is my x squared. So since I'm going to build 3x squared, this 3, so instead of 1, it's going to be 1, but this time 1, 2, 3. The graph is going to go through these points. 3x squared. So I'm going to have much more narrower, right? Okay, this is going to be my 3x squared. Now I'm going to work with this 3x squared. 3x squared, I have to shift by 6, positive 6. Let's do it. 1, 2, 3, 4. 4 is this. Let me. 3, 4, 5, 6. Okay, I'm going to shift by 6, which means I'm moving this y-axis here. Okay, and where is 3? Here it is, this 3, and here is plus 1, minus 1, these points. Okay, which means the new graph is gonna look like this. And now let me connect. Okay, I think it didn't come out as narrow as it's supposed to be. Maybe I took this point too far. Ah, of course I took this right here. So it's gonna go. So this is gonna be 3 times x minus 6 squared. Okay, and the lastly we are going to do minus 5, right? Bring down by 5. This the 3 times x minus 6 squared, take it and move down by 5. So let's see, 5, 1, 2, 3, 4, 5. Okay, it's gonna go through here. This is negative 5. Okay, so what color are we going to choose so it will look nice, so we can see? I don't see anything nice, but I'll use maybe this one. So this graph, okay, so this one is coming here, this one is coming here, okay, and it's gonna be 1, 2, 3. So the graph is gonna be, let me make it bold. Mm-hmm. For somebody who doesn't know how to draw, it's not bad. The only thing is this vertex looks like sharp. It's sharp corner. It's not sharp. It's supposed to be smooth like this. So this is going to be final answer 3 times x minus 6 squared minus 5. Take a guess, what is this point, vertex? It's going to be positive 6 and negative 5. There we go. Question number 14. It takes too long. Maybe it's too long video. I'll tell you what, let me stop here and then in next video I'll go through, excuse me, through 14 through 20, okay? All right, I'll record next video starting from 14, so it's coming out way too long, so you won't get bored. It won't be too much. Okay.